And we'll zoom it so we can see. I think I moved everything, so oh. It looks like a shadow, but it's the box. Fortunately, I can't get the box out of it. If I had something proper, maybe it would work. Okay, this is actually wrapping up chapter 11. Not a big deal for us because we're going to keep going in chapter 12, which is very, very short. So we're going to finish everything, which is good. So this is what, 11.7, I think. All right. And so we're going to work with spheres, okay? And so spheres do not have a lateral area. Can anybody tell me why spheres don't have a lateral area? Yeah.
That doesn't have bases or sides.
It doesn't have bases. It's just a ball, basically, right? So all we have for spheres is a surface area. And the surface area is just going to be 4 pi r squared. Okay? So let's go ahead and look at a sphere. Let's see if I can draw it here. Okay, of course the sphere has a middle point. And so this circle, basically, if a plane contains the center of a sphere, then its intersection is a great circle of the sphere. So basically the great circle is the biggest circle you have in a sphere. So I could just pivot this circle on this point and it would create the sphere. So that would be the great circle. That's as close as you get to a base. Okay, so we're going to need a radius. Be careful, sometimes they give you a diameter. So we're going to do just a little example of this and see if we can get it right. Let's pretend that radius, let's call that radius for, let's find the surface area as a sphere. Okay, it's just all calculator, right? We just do 4 pi 4 squared.
201.06.
All right. So that's going to equal two different things. It's going to equal 64 pi. And so I'm going to probably ask for it rounded on this chapter. So rounded would be basically 201.1 if I round to the nearest tenth. Okay. Piece of cake, right?
Do we have to have both of those answers?
It just depends what you're asking for. And so you don't necessarily have to have both. It just depends. For our purposes, this chapter, we're going to focus mainly on this one. Of course, I probably would need units squared also. Okay, so all these things are going to have units like feet or meters. All right, so we're going to actually move on because we're done with chapter 2. We'll go done with chapter 11. We're going to do chapter 12. And so we're going to look at this formula for a sphere. And let's see if you can tell me what this formula would be for. What do we think V stands for?
Volume.
Stands for volume, right? Okay, so surface area, let me see if I can get this all on the same screen. This is the outside. Volume would be the inside. Okay? So surface area would be like, on a basketball, it would be like the orange leather, right? The inside would be the air. Okay? So in this room, you paint the walls, right? And you can paint the floors and paint the ceiling. That's surface area. But if you filled this room with water, that would be filling the volume. So that might be very scary, might be very fun. But still, that would be the volume. Right now, the volume of the room is filled with a little oxygen, a little nitrogen, some carbon dioxide, right? Hopefully, no argon or anything deadly. All right, so moving on. So volume, again, all we need is radius. And so that's all we're going to need to do. And so we're going to find the volume of this same. Well, I'll draw another sphere, just for fun. Just so it can fit in this narrow picture that I have. So let's do it with diameter. Just to practice diameter. So that's the diameter. So the diameter equals 12. All right, let's see if we can, let's call it actually with a unit. Let's call it 12 miles. Okay, that would be a very big sphere, right? Okay. So what are we going to put into this formula? We're going to put in 4/3. We're going to put in pi. What are we going to put for r?
6.
6, because radius is half of. Okay, does everybody know how to do this in their calculator? Let's see if I doubt this will work with the calculator. I don't think the calculator can fit in the narrow window. Yeah, I can turn it sideways, but that's a thrilling video, especially since it doesn't seem to focus very good. To put in cubed, just use this thing. So this would be 6, that button, to the 3rd. Imagine what it was before we could use calculators. These were very, very, very time-consuming problems.
Oh gosh, they probably were.
Oh, they definitely were. Let's see if I put this in my calculator right. I first got 288 pi, and then that should be like 904. 0.8 if you round to the nearest tenth. And this is actually going to be miles cubed. We measure volumes in cubes. It would be hard to measure them in surfaces because it's not a surface. It is basically everything filling inside between two surfaces. So we use cubed. And that's basically it for that. I'm going to throw in one more thing on this. And it's not going to be that big of a deal here. Because we've kind of gone out of order a little bit. So this is the last thing we're doing today, and it's real easy. We haven't gone over naming. Names of our polyhedron. Okay. We know it. What are polyhedron? Do we remember? It's basically 3D shapes. I'm going to make sure I don't spell it wrong. Okay, so basically what you're going to do for a name is you're going to start with the base. And then you're going to add, well, for our purposes, we only have a few names. We're going to have prism. We're going to have pyramid, right? If it has a circle, you just get one name for some reason. Okay, so let's see if we can do this real quick. If you have a circle, you just basically have three names. So I'm going to draw a shape, and you just tell me what it's called. And let's see if I can draw something good. See if you can see what that is. What do we think it is? Pentagonal prism. No, pentagonal pyramid, right? It's a pentagonal pyramid. I can't make this hard if I tried. Okay, so I'm going to pass this out. Do the naming stuff first, and then we'll work on the other stuff. We probably won't get done, but it's fine because it's not going to be due till Tuesday anyways.
So when naming polyhedrons, you just say the base, then you say what shape it is?
Yes. There are polyhedron with specific names, and I'm going to give you some of those at the very, very end if we have time. But the main polyhedron we're studying are pyramids and prisms, so that's how you do pyramids and prisms.